Which of the following aqueous solutions have the greatest increase in boiling point compared to pure water? So first we have to identify what type of equation we're going to be using. So this is going to be the change in boiling point temperature equation. So this is our equation. This is the change in temperature of the boiling point. This is the Van't Hoff factor. This is the constant, and this is the molality. So starting off with I, the Van't Hoff factor, this tells us the amount of particles the solute produces in the solution. The constant is going to remain the same if it's part of the same solvent. So if it's all in water, and as you can see, it's all aqueous, so that means they're all in water. So this is going to be the same for all of our compounds here. And the molality is going to be the number of moles divided by the kilograms of the actual solvent. So let's start with our first one. So because these are all aqueous solutions, like I was saying, they're all going to have the same Kb, so that means that all of these are going to be the exact same for all four of our answer choices. And basically we're comparing our I and M, so our Van't Hoff factor and our molality. So let's start with A. So we have 0.10 molality, so it's going to be I times 0.10, and then we can see our I is going to be actually 3. So why is our I 3? Well, because this is an ionic ionic compound, this is actually going to dissociate into 3 different particles because there's 1 magnesium and 2 chlorines. So that's going to be 0.30. That's going to be the amount that our temperature increases in our boiling point. Now let's try our second one, so B. So we have 0.20 times. Now you might be thinking, oh, is this going to be like 10 for I? However, this is actually a covalent molecule, so that means all nonmetals. So that means that it's actually not going to dissociate into ions, so it's our Van't Hoff factor is only going to be 1. Now for C, we have our 0.15 molality, and then this is going to have 2 sodiums and 1 sulfur, so 3. Now for D, we have 0.20, and then AlCl3 is going to be an ionic compound, so that means it's going to dissociate into 4 different particles, so aluminum, chlorine, chlorine, chlorine. Leading our answer choice to be at 0.80. Comment down below what you want me to cover next.